Hi, this video is about the standard error, and remember we're working up to this confidence interval formula. So here's the confidence interval formula again. In the last video we found the Z star, and we found those 4 confidence levels. So I'm going to write them in here. 2.5758, 1.96, 1.6449, and 1.2816. Okay, so we'll be using whichever number corresponds to our confidence level. Now I want to talk about this part of the formula right here. This is called the standard error. Okay, so let's do that. Standard error, what it is, it's an estimate of the standard deviation. Since we don't know our actual value, we don't know our population proportion. That's why we're doing statistics in the first place, right? There's something we want to know, but we don't know, so we take a poll. We take a survey. So all we have is p hat. All we have, like for example in the healthcare survey, all we know is 60% of the sample said yes. So how do we estimate our standard deviation? We need to know, we figured out how many standard deviations we need to go out, but we need a number for the standard deviation. So we're using the same formula that we used with sampling distributions, but instead of p, which is the true proportion, we don't know that. So we're using p hat, which is the sample proportion. So remember, whenever we put a hat on the p, that means it's coming from a sample. Okay, so let's do an example where we calculate this standard error. So we have a survey of 2,000 hiring managers showed that 1,200 use social media sites to research job applicants. State the sample proportion and calculate the standard error for this sample proportion. Okay, so this is a great problem because it doesn't give us the proportion right off the bat. Sometimes it will give you the percentage or proportion. Sometimes it gives you the number. So we have to calculate our p hat in this case, which is the number who said yes, 1,200, out of the total, which is 2,000. So let's calculate 1,200 divided by 2,000. Wow, it's also 0.6. What a miracle. Okay. 0.6 or 0.60. So that is our p hat, 60%. And then our standard error, which we use SE. Standard error is an estimate for standard deviation, but we use standard error to indicate that it's calculated from p hat, not a proportion, not a parameter. So many p words. So our standard error is going to be 0.60. Remember, q hat is the complement, it's 1 minus, so in this case 0.40, over our sample size n. So our sample size is 2,000. Put it over here. Square root 0.6 times 0.4 divided by 2,000. So you can see the standard error depends on how big your sample is. The bigger, and we saw this with sampling distributions, the bigger sample you take, the more narrow your standard deviation will get. 0.010, it would be 9.5, but that 5 would round that to a 10. So 0.110. Okay, so this is our standard error. This is our sample proportion. Okay, now remember those conditions. Those are not going away. Check the 4 conditions needed to use a sampling distribution for p hat. Meaning this standard error, this formula doesn't mean anything if the conditions aren't met. The conditions have to be met in order to use that model, the normal model with this standard deviation. So remember the 4 conditions? Let's go through them. The first one's independence. And let's think about our context here. What do we need for these to be independent? Would these hiring managers be independent from each other on whether they use social media sites to research job applicants? So I think this is really industry dependent. People in business might tend to do this a lot more versus people in the public sector, in education or nonprofits, may or may not use social media sites. So I'd say we would need to get a representative sample from different industries and different occupations, things like that. We would need a representative sample of different sectors, like public sector, private sector, industries, regions, etc. Kind of like in the healthcare poll, how they stratify, or they didn't exactly stratify, but they made sure that they got a representative sample. Okay, second one, remember what it is? Randomization. Do we have a random sample? Now this one does not say, so let's make sure. We need to take a random sample. We can't ask everyone at Google or something like that. Okay, what's the third one? 10% condition. Okay, would this be sampling with replacement or without replacement? So we're surveying 2,000 hiring managers. We wouldn't ask someone twice, right? So this is without replacement. So that means the 10% condition does apply. When sampling without replacement, we have to make sure we're sampling less than 10% of the population. So without replacement, so this applies. And then what do you think? Is 2,000 less than 10% of all the hiring managers in the whole United States? I would think so, because that would be 20,000. So let's write 2,000 is less than 10% of all hiring managers. So I'm putting the context in there for the population. Our population is all hiring managers. Okay, the fourth one, remember what it is? Now that's the one that's different between means and proportions. Here we're talking about proportions, so it's called the success failure. Success failure condition. And that's the one that says n times p has to be greater than or equal to 10, and also n times q has to be greater than or equal to 10. That is so that we can make sure that we have a normal distribution. If the p is very big or very small, you have to have a much bigger sample size in order to get a normal distribution. Okay, so let's calculate this. Our n is 2,000 and our p is 0.60. And I'll do NQ at the same time. Our N is 2,000 and our Q is 0.40. So let's multiply those together. 2,000 times 0.6 is 1,200. Oh, that makes sense because that's what we got. 60% said yes, which is 1,200. And that means the rest is 800. These all always add up to n. Okay, so this is greater than or equal to 10, check. Greater than or equal to 10, check. Okay. So, yay, we can do this. Now, let's draw out the distribution. I'll come back to this wording at the bottom in a minute. Let's draw out the sampling distribution. We have a mean of 0.6 and a standard deviation of just a little over 1%, 0.110. So I'll do 0.01 for the drawing. And remember, we always want to put the more digits into GeoGebra, but for the drawing we can make it a little more simplified. That's kind of nice because then we can go 0.61, 62, 63. I think also in general it's easier for people to conceptualize with fewer digits. The more digits you add, it's just like, it's harder to figure out what that number is. So this is 60%, 61, 62, 63, 59, 58, 57. Okay, let's label this too. So what do these numbers represent again? We're talking about the percentage of, let me pull my context down here, percentage of hiring managers that use social media sites to research job applicants. Okay, so let's say the proportion of hiring managers who use social media to research job applicants. And then one more thing I want to add to this, in samples of 2,000, because if we change to a different sample size, this graph will completely change, right? Our standard error is based on our sample size. So in samples, let me get it on here, of 2,000. Okay, so far so good. So we found our sample proportion and our standard error, which is our estimate for standard deviation. And now think confidence interval. We found this value and we want to know, well, is it between 59 and 61%, 58 and 62%? That's what depends on our confidence level. So if we want to be about 95% confident, it's almost 2 standard deviations away, right? So the 95% confidence would say this would be about 58 to 62%. Now I'm estimating a little bit based on the empirical rule. If we want to do it exactly, then we would take 1.96 times the standard error. And that's what we would get for our confidence, or sorry, for our confidence interval. Okay, so let me just check the next page here. Yeah, okay, so I'm not going to write this down yet because it's on the next page. But keep in mind that since we're looking at 95% confidence, it would be around 58 to 62%. Okay, that would be that's an estimate for our confidence interval. And in the next video, we'll go into margin of error and we'll get a little bit more precise with that. Okay, so see you there.